Saules paneļi. Tu brauc un skaties, ļaudis uzstādījuši saules paneļus un domā, lūk, veiksminieki, lūk, cilvēki, kas māk ielikt pareizajā vilcienā īstajā brīdī. Un tad jautājums ir, vai mājsaimniecība atceras ieguldīt arī ugunsdrošībā? Jo īpašumi, kas aprīkot ar saules paneļiem, kļūst potenciāli uguns nedrošāki. Pašbrīd tam, ka tu kā īpašnieks domā, saules panelis, tur jau nekā degošana nav, bet nav jau stāsts tieši par pašiem paneļiem. Tāpēc sagaidām Energy Decisions Limited direktors Roberts Lapsevskis. Mūsu nākamais viesis. Welcome!
Sveiki! Labdien! Mans sauc Roberts Lapsevskis. Prezentācija būs angļu valodā, bet, ja ir kādi jautājumi pēc tam, varat droši arī latviski jautāt. Hello, my name is Roberts Lapsevskis. I'm a director of Energy Decisions Limited, and I will be presenting about lithium batteries and solar panels in context of fire safety. A little bit about myself. We provide consultancy services and also design and installation services of PV systems. At the same time, I'm involved in other areas. For example, in Latvia, I'm teaching a course for solar PV installations about design and installation methods in Mācību centrs Magnum. I'm also involved in a technical committee of IET in UK, which is responsible for producing codes of practice for safe design and installation of battery storage systems. So let's start on this presentation. So in this case, I'll be focusing more in context of latest regulations and advice for the system design from UK perspective, which would be very similar across Europe, but that's the area I come from. And our agenda for this presentation is we will start with fire safety in solar PV systems, and then we will talk about lithium-ion storage batteries and look at the batteries in different contexts. So what do we know with lithium batteries, solar panels? When we look at statistics, International Electrotechnical Commission in 2021 commissioned research to find out how many failures in solar PV systems happen. And it was about 70%. It was down to installation errors and product defects. A few years earlier, in UK, organization BRE did a slightly different focus on the research and found out which are the most faulty components, and DC components contributed about 70% of the failures. So when we talk about fire safety in a PV and battery storage context, we will focus solely on a DC part of it, since faults associated with alternating current would be common in other installations as well. So if you take anything from this presentation, it's workmanship, installation quality, and DC faults. If you can eliminate those on your job, your site, you already have managed to solve most of the issues. When we talk about solar PV system, people generally think about, there are PV modules and then there is inverter. Is there anything else in between? There are DC connectors, there's cabling, isolators, surge protection. There are various parts, various components involved in a system. And most of DC faults will happen due to DC arcing, which could be caused by faulty DC components, connectors, switches, poor installation, damaged wires. And what can we do to prevent those issues is generally, where we can, we try to use factory-made patch cables, regular inspection and testing, arc fault detection systems, we could consider use of optimizers and microinverters. Those devices will limit the DC voltages on the system, and that would reduce the risks and dangers of DC of the DC arc magnitude. At the same time, we need to take into account that once we introduce things like that on the roof, we are increasing amount of connections, and it might not be the best place for power electronics on the roof in a heat under the modules in long term. But generally, those are factory-made products, so risk would be significantly lower. So looking at this PV system, a general picture would be something like that. When we're looking at the building, we have our mounting kit for the system, we have our modules on the roof, and then we have all our components up to the inverter on this DC side, which we are discussing. And after that, we have a connection to the grid on our AC side. What are the most common faults? So what we discussed was those connectors. I can't stress enough. DC isolators and DC connectors are the number one failure by a large margin on faults on our systems. All of those systems in a PV systems are sort of interconnected. There could be faulty part, bad workmanship, design failure, and all of it ultimately leads to a system failure. But we'll try to somehow group them to give an indication what and where we can do. So when we look at installation issues, poor installation, that is an issue. Often it's caused by not following designs, not following manufacturer's instructions. And a very common part would be DC cables under the PV modules wouldn't be fixed or wouldn't be installed in adequate trunking, so they would be left loose to hang around in a wind, and cables could get damaged. So securing cables is a very big part what we can do to improve the situation. Another thing is incorrect devices. Sometimes there are confusion between AC and DC components, and they are supposed to be used for its own intended purpose. Don't get confused with them. Incorrect polarity, wrong cable termination, wrong torque settings, as well as damage in the roof where we haven't properly sealed entry points in the roof. We can get water ingress, which could present problems with our electrical installation in the future. So prevention mostly would be following rules, standards, and quality control, supervision and training for the installers. Quality of components, I would say we should be using reliable, trustworthy manufacturers and suppliers. We look for CE mark that components are good quality, so we know that the cables, switchgear, surge protected devices, inverters are good quality. And we have to be careful about compatibility. For example, DC connectors, which are often referred as MC4 connectors, since the largest manufacturer calls them like that, often are used from different manufacturers, and they are not designed to work together from different manufacturers. Those are part of those failures we discussed before. Again, supervision and use of correct IP rating devices as well. Environmental conditions. When you look at environmental conditions, there are a lot of things that could go wrong. Lightning strikes, falling debris, extreme weather conditions, vandalism, pests, pest chewing cables, that happens. Direct sunlight, which wears the parts down over the time. Leaves collecting on module systems, storing flammable materials near PV systems. So we need solutions for all of those. Again, good design, good practice, installation of surge protected devices, earthing, grounding, site security, installation of bird protection, not allowing them to build those nests, rodent protection, thinking about the PV layout so we don't keep our modules in a place where we have risks of fire hazards from other materials. Design and layout. Here I have added a screenshot of popular software used for designing PV systems. Assistance of software can be very helpful to see if correct combination of PV modules and inverter and or optimizers is used. But manual checks are always necessary. Software will tell you only what it sees from information you have put in. So knowing the software is really important. But what we have often experienced is missing compatibility between components, where modules are selected with some ratings and installers want to install more modules than inverter actually can take, and they haven't checked extreme conditions in the very cold or very hot weather and things like that. So what we would be recommending for design and layout as a solutions would be basically it's training for designers. Use software provided by manufacturers. Many manufacturers will provide software tools where you can check if their components will work together correctly. Another thing would be in design, maybe too dense clustering of solar panels together, not leaving escape routes and fire barrier issues. Thermal risks and hotspots. We get hotspots from solar panels if we have damage in modules, or if we have maybe a design failure where there's a constantly shade at some parts of the modules. And again, those things we try to fix by good design and good ventilation as well for the modules, and definitely maintenance. Keeping soiling away from the modules, and regular inspection and maintenance of the system. Thermal cameras are really good help where we can identify those hotspots. Then we have aging. As everything, solar panels will age as well over the time, and components over the time just get less reliable. Another thing to do with aging, which often is not considered, is what happens on our site. Maybe we installed our PV system and everything was great on the day one, but after a time, new building was erected nearby. Trees grew taller, some vegetation grew on a site or was introduced later on. And it means that system is no longer in conditions as it was designed. We need to deal with that. What do we do? Regular maintenance, inspection, and good future-proof design, where we could take into consideration what could happen on our site in the future, and how do we install other components, not just solar panels, for example, switches and inverters. We would like to introduce some cover from rain, snow, direct sunlight, flooding, mechanical damage. For inverters, it's important to give them enough ventilation area around it so we can get airflow, especially on domestic installations. Many smaller inverters no longer have fan-assisted cooling. They rely on convection, so they need space around them so they could keep cool. That would be in short, about safety about solar panels. When we look at the battery storage systems, then we could see in here's picture. So on the roof we have solar modules which would be connected to inverter, one of those boxes down there. And if we have a battery storage system on the site as well, batteries will be connected to the inverter. What's the biggest difference between those two systems, PV and battery storage, is battery management system. That is a crucial part of battery storage system. So this system can be integrated into batteries, or it could be a separate unit. We'll talk about it a little bit later, a bit more about it. So for the risks, when we looked at the fire risks for the PV systems, we just listed what's there, and for battery storage, one very different and more crucial part maybe even is thermal risks. And this big scary thing that everyone's talking about in lithium batteries when we talk about the risks and safety is thermal runaway. So what is thermal runaway? It's basically when there is a fault on a system and heat is being produced quicker than it can dissipate from the system, and we get a chain reaction which results in ejection of gases like hydrogen, carbon monoxide, hydrogen fluoride. Those are flammable gases which are toxic and corrosive, and this is the point we really try to avoid. And when we look at how can we get to this terrible situation, it's generally the most risky parts in a battery life is charging, and especially late stage of charging when batteries are very full. And this is where our battery management system comes in. If there are faults, that's where the risk is higher. In general, what else could go wrong with batteries? It's mechanical abuse, penetration, crushing, dropping of battery systems, electrical abuse, internal short circuits, overcharging, over-discharging, thermal abuse, which would be overheating, often external. For example, if there is a fire outside the place where the batteries are installed. And aging and environmental effects in a similar manner as it would be for any other system. We could list as well seismic activity, rodent damage, flooding, and other things which would be common with other systems as well. So those are things that could cause thermal runaway from external part. When we look at battery itself, when users might think, my battery system is doing fine, I have protected it from vehicles which could crash into them or any other things like that, but still overheating could happen internally when visually you might think the system is fine. Overcharging the same. Those are failures we don't see visually. So how do we deal with those things, and how do we avoid those thermal runaways? We deal with risk management, and what I'll do here is now I will list some of the methods which are commonly used to not get to this point where we need firemen and where we need to fix the situation. So the first part that is worth mentioning is battery management system. So basically that's a system that will monitor and manage the critical parameters of lithium batteries like voltage, current, temperature, charge rate, discharge rate. Very important part of the system. Then we look at installation and location. Where do we install the batteries? Is loft space the best place? Generally, answer would be no. We try to install batteries where we can have a fire-resisting barriers between batteries and rest of the system. Provide ventilation. We avoid installation of batteries in high-risk places like sleeping quarters, escape routes, lofts, for example. Thermal management. We can do it in a passive way, install batteries where we try to keep them at the temperature they're most happy at, which is similar like humans. put the batteries in plus 15, plus 20 degrees, they'll be happy. If that's not a possibility, we introduce thermal management. Those could be cases like this, which could provide cooling and heating for the batteries, or those could be other systems which are air-cooled, water-cooled, and together with heating. Mechanical protection is done in a sort of a similar manner, generally by enclosures or placing batteries in a location where those risks are minimized. We provide regular monitoring and maintenance. This is really important part. Batteries generally now will always, those systems, monitoring systems will be connected to the internet, and because this is a new technology, development goes on all the time. It means that manufacturers regularly discover new things, how to more optimally operate the batteries. So if you have internet connection, you could even get periodical firmware upgrade, which would modify how system manages batteries, increasing safety. And what do we do with emergency issues? It's recommended in places where we install batteries, if it's not maybe somewhere outside and far away from any risks. If it's somewhere in a house, we do install fire detection systems integrated together with our systems. If the faults happen, they are very quick, and you won't have time with those systems to look at them and think about what to do. You need integrated system for fire safety, meaning if the battery is installed, for example, in a garage, we need a linked fire alarm system. So even if you are in bedroom, you can hear that a problem has happened. Training and awareness, very crucial part. This is a new code of practice, literally released yesterday. Very valuable information about the batteries. Myself, I've been a part of technical committee preparing this document. Would really recommend looking at that one. And every person involved in those systems, I would say we need to look at the training and awareness of rules and system design. So we need to follow local laws, regulations. IEC standards provide very valuable information. And then we have things like codes of practices, for example, this one, or PASS documents. In UK, BSI have produced new PASS document, came out only 2 weeks ago, PASS 63100, which is to do with battery installations in dwellings. So those publicly available specification documents are very valuable. They are released quicker than, for example, full standards, so we can get where we need very quickly. And last but not the least is end-of-life management. You have to plan for a recycling or disposal of battery systems before you install them. Follow manufacturer's guidance, include that in operational manuals for the systems, and consider also transportation and things like stranded energy. When we disconnect the battery systems, they could have a lot of energy in them, so if they would be discharged, that would be obviously much safer. After batteries, let's very briefly talk about the electrical vehicles. They will contain generally lithium batteries at the moment, most of the time. Just few quick tips. The most dangerous thing, again, is charging moment when vehicles are being charged. So we try to keep them away from emergency exits, emergency routes. When we charge them, let's try to keep them with a gap between the parking bays, designed similarly as would be maybe done for disabled parking or something like that. We'll keep about 1.2 meters between the cars, so if there's issue, it doesn't jump from vehicle to vehicle. Let's not keep flammable objects nearby those points. And if we charge electrical scooters or bicycles, they should have secure fire compartments, or they should be charged in detached single-story buildings. Those at the moment are the biggest issues in the lithium battery field. Low quality electrical scooters and bicycles, they are the ones that catch fire. Don't charge them inside your house. When we charge any electrical vehicle, we need to use appropriate charging device, which is designed for that unit. No DIY devices and things like that. And we charge them in designated places. So there should be markings and basically designation for each type of unit we are charging. If we are charging vehicles in multi-story car parks, it would be a good idea to design them keeping in mind that fire could happen, so we have a good access for fire services. And if it's happening underground, sprinkler system should definitely be considered. When lithium battery catches fire, really it wouldn't be recommended to trying to tackle them. Just get yourself out, get in safety. Generally, the firefighting involves adding large amounts of water in those batteries just to cool them down, to stop the thermal runaway and let them to burn out. If it's something smaller, it could be submerged in water, but we shouldn't be engaging in lithium battery fires as individuals. We leave it to professionals. And that's about it in 25 minutes, what we can discuss about PV panels and battery storage. Please, if you have any questions, I'll be happy to answer them.
Thank you. Jā, aplausos, Robertam. Paldies jums. Jautājumi? Any questions? Hello, Bogdan. That's our next speaker, Bogdan Rachenga.
Okay, thank you very much, Robert, for a great presentation. My main question is, if you analyze, if you have any statistic for the UK, where's the main cause of the fire in the PV installations? Because we are already doing some fire tests for the PV installation, and there was some analysis from our side. So I'm curious if you found exactly the same.
Yeah, I think the most popular document in this area would be BRE research from 2017, which identified which components would be mostly involved in the fires, and that would be DC components, DC isolators, and there's lots of discussion, could we actually get away with not installing DC isolators and having equipment with isolators built in, since it's a very large problem, especially from installer's perspective. Lots of bad workmanship, not using correct ferrules, not using correct cables, not terminating them correctly and getting those arc faults. And MC4 connectors or DC connectors, very common issue. They so often are not terminated correctly. Large part of my job is when I see different installations or I meet new contractors, I would actually show them how to do those connectors correctly. In MC4 connectors, once we get the moisture ingress there, we have corrosion, we have arcing, it's just a ticking time bomb. So those are the most dangerous things which causes the most fires.
It's very good. We find exactly the same for the MC4, and in Poland there are already the insurance who require from the installation companies special certificate, because then the house will be not insured at all if the installation is not done correctly.
Yes, it's insurance companies are probably driving this process quite a lot these days. Once insurance company says, well, if you have a solar panels, battery storage, you need certain qualifications for your installer to commission this system, so they feel safe that it's not going to introduce another risk to the property. That's what they ask for, and they are producing lots of actually very useful materials with a good practice guide, and they have produced even guides about electrical vehicles, which sometimes is a bit hard to see from practical perspective. For example, there's a guidance of keeping electrical vehicles at least 6-7 meters away from the buildings, and in a domestic environment, it's not always possible. So we need to sometimes find other options how to deal with potential issues.
Especially if you use electric vehicles as batteries for the solar panels.
Yeah, that's a new thing which is for a couple of years already available, where battery as a storage vehicle to grid vehicle to house. That's definitely is something where market is going to.
All right, thank you very much. Thank you. Paldies. Paldies, Robertam. Ļoti daudz, kas vēl diskutējams, noteikti, Roberta, noķeriet un arī izjautājiet. Jā, viens certifikāts lūdzu un arī bilde. Foto. Smaids uz kameru. Paldies!